Today we're looking at how Tayobi's TiCS framework integrates into Gitlab. The TiCS framework is Tayobi's way to standardize software quality measurements across different languages and technologies. Using an independent, third-party method, your code is subjected to a range of different static analyzers that find all kinds of interesting things, from areas of high duplication or complexity to real bugs like null-pointer exceptions and divisions by zero. The framework runs on-prem and integrates directly into Gitlab. This allows you to measure your quality on a continuous basis and alert engineers quickly on a degradation in quality. So, how can we integrate software quality directly into our CI/CD pipeline using Gitlab? This merge request was stopped because a quality gate in TiCS failed. A quality gate is a way to ensure engineers do not merge code which violates certain standards or rules that an organization has agreed upon. This ensures that quality will never deteriorate when adding new code. As can be seen here, the quality gate has failed and the merge request has not been approved. The conditions which made the gate fail are also stated. Apparently, the engineer introduced a coding standard violation of level 1, 2 or 3, which are the most severe violations, as well as a compiler warning. TiCS detects this and displays in the merge request why the gates have failed, and also for how many files. We can also see in which files these violations were introduced. Let's take this file as an example. When we click on that file, we will be taken to the Changes tab within Gitlab. Now that we've arrived at the Changes tab within Gitlab, we can check and get an overview of what has changed and how that triggered our quality gate. Here we see which code snippet triggered the quality gate to fail. Let's focus on the first quality gate for a second. We see that the error occurs at line 101, where the function scanf expects a different type of argument than it is given. That is definitely a mistake, but thankfully we have stopped the merge from happening so the engineer can correct this. When we want to dive a bit deeper into the quality gates and what went wrong, we can also directly access our TiCS viewer, which is the main dashboard of the TiCS application. We see a similar overview as we saw in Gitlab. Which quality gates have failed, why they failed, and in which files the violations are situated. Additionally, you can configure all kinds of other metrics you'd like to see as well. But let's click on the file like we did in Gitlab. We'll use the same file as before, isystem.c. This brings us to the annotated source within TiCS, where we see the file as it was before as well as what was changed. It also shows us a summary of the violations. From this view, it is also easy to switch to other software quality metrics and explore the general quality of your file or your whole application even further. The overview in Gitlab we saw earlier serves well in giving us the information we need on why the merge request was blocked. But to better understand how to improve our code to ensure the merge request will be accepted next time, TiCS also provides us with so-called rule help. Tayobi maintains multiple coding standards for large organizations like ASML or Philips. These standards are available to all Tayobi customers and are checked automatically by the TiCS framework. The Rule Help button allows you to instantly see some examples of why you violated the rule and oftentimes also advice on how to improve your code. In conclusion, using TiCS and Gitlab combined together allows for developing higher software quality integrated directly into your software development lifecycle.